Tutorial sheet 1, question 11. We're given two functions, h of n, which is equal to an impulse, which is shifted from n to n minus 1, plus just the impulse function. And these, again, because of the square brackets, are discrete functions. And the question asks us to show that the system acts as an edge detector by using this function u of n minus 7 as the input. Well, first of all, we need to know what these two functions look like, and I've sketched these already down here. So we have h of n versus n. So we have our first impulse, which is at n is equal to 0, which is this part, and our minus impulse function, so it's got a negative at n minus 1, so it's shifted to n equals 1. So that's what h of n looks like, and if I complete that, you have x of n is 0, because it's just a unit step. It's 0 for every time where n is less than 7. So at the time n is equal to 7, we get 1 continuing to infinity. So I've already drawn out the box that we need to do the convolution, so we're going to work out y of n is equal to the convolution, which is k minus infinity to infinity of, in this case what we're going to do is we're going to have x of k, and we're going to flip h of k to n minus k and carry out that convolution sum in this case. So what we need to do first of all is write down x of k, which I've just used values from 3, so we don't have to do everything back to 0, and so at k is equal to 7, we get the output becomes 1. And again we can flip this function, so we're taking this h of n, we're replacing n with k, and then we flip that function over and shift it to minus infinity, then gradually move it forward, and nothing happens in terms of the output. There's no non-zero output until n is equal to 6. And when n is equal to 6, well, it's just before we have anything interesting happen. So the output is still 0 because there are still no non-zero multiplications. And as we shift to n is equal to 7, so we move this 1 to the right, we've got 1 multiplied by 1, so we get an output of 1. If we move to the right again, well, in this case we've got 1 multiplied by minus 1 plus 1 multiplied by 1. If we move it to the right again, we have the same thing occurring again, 1 multiplied by minus 1 and 1 multiplied by 1. And of course x of k will continue being 1 for infinity, but this multiplication of 1 multiplied by minus 1 and 1 multiplied by 1 is always going to give us an answer of 0. So we can see here as our input, which is has this rising edge here, at n is equal to 7 we get 1 output. So this tells us this is an edge detector because we have a rising edge on our input signal, and we are only going to get 1 non-zero output at the time n is equal to 7 where this is an edge, a rising edge. So that shows that this is an edge detector.